Hello guys, welcome to session 5 of exploratory data analysis. So today we learn what is exploratory data analysis, and we also do a example. I will show you example on how to take a data set and you can perform EDA on top of that. So EDA is a kind of an ocean itself. So there's many things you can do in EDA. Uh, but today we focus on mainly few steps, basics only. So yeah, let's get started. First, let me tell you which data set today I'm going to take. So I'm taking the data set of students' habits versus academic performance. This data set, you can search it on Kaggle. So the data set, let me show you the data set. So this is the data set. You can see there are around 15, 15 columns, which are students' ID, 16, 15 columns, age, gender, study hours per day, social media hours, Netflix hours, part-time job, attendance percentage, sleep hour, diet quality, exercise frequency, parental education level, internet quality, mental health rating, extracurricular participation, and exam scores. So this is basically dummy data. Okay. So let's start with the EDA step one. First step is overview of the data. So I will be using Google Colab for performing EDA. I found it easy. You can do it on any platform you're comfortable with, whether it's PyCharm, Anaconda, Jupyter Notebook, or anything which you feel comfortable. Okay, so I've already uh, coded it down, so I will be able to explain it to you. So first, you have to import all the libraries which are required to perform EDA. Yeah, the number of these are the number of libraries. You can see NumPy is important. NumPy is basically numerical Python. Pandas, Matplotlib to visualization, and Seaborn as well. This is the graph type that I have selected, 538, and this part you can ignore. So first, this is where you have to click on this folder icon, import the data set. I have already imported the data set from this. You can see when you click on this button, upload, you can select the data set and upload it on Google Colab. And first command is you have to use panda read underscore CSV to open a particular file. We have opened it. And first thing you do is overview the data. So it's basically, if you do df.sample, it will give you uh, randomly three rows from the data set. So you can see the three rows are visible and all the columns are there. There are 16 columns and the total row of the data set is 1000. You can check it by df.shape. We have checked the shape. And df.info, you can get all the idea of which column is from which data type, and not null contain how many values from the column are having a not null value, which is some value like integer, float, or anything, but not null, not empty. So here you can see there are few columns in parental education level which are null values. So around 91 values, I think null value. So here I have checked how many null values are there overall in dataset. So here you can see there are 91 null values in parental education level. After that, it is a description of data. You can see it's a 5-point summary if you heard the name. So there are numerical column wise, mean, average mean, standard deviation of particular column, minimum value of that particular column, 25 percentile, 50th percentile, you can also see the median value, 75 percentile, and maximum value of that particular column. Okay. So here you can see by checking all the values, you can see there are not as in exam score section. I think this standard deviation is 16. So what standard deviation represent is how your data is spread across mean. If you have seen the graph of standard deviation, it will be easier to visualize. So this is the graph of standard deviation. Yeah. So this is the graph of standard deviation. This is a one standard deviation. So standard deviation basically tells you how much your data. This is actually standard normal variant, standard normal variant. So in which you convert your mean to zero. So if you, as of now, if you're not getting it, just ignore it. So imagine this is a mean, there might be a graph for mean as well. Let me, this graph. Why it's taking too much time? Yeah, here is the mean. You can see it's mostly on the center part. And when you calculate the standard deviation, this is sigma, it will tell you plus or minus standard deviation how your data is spread across mean. Okay, so I think this is a really perfect example to visualize it. This is the case, and majority of case there is a empirical rule applicable in standard deviation, and when it's normal, so you can see that this is a normal bell curve shape. If it's normal, so almost 60%, 65% of data is spread between one standard deviation, 95 between two, and almost 99% values has been spread across three standard deviation, plus or minus three standard deviation. So you can consider any values more than three standard deviation away as an outlier. So you can see there are chances of getting the outlier is 0.1 and 0.1. So if your mean value is something, the standard deviation 3 plus or minus 3, the value is spread across uh, in a large distance. Okay, so let's back to the collab. So here you can see by checking mean and standard deviation, you can see here in age, average age is 20, standard deviation is 2. So all of the majority of all of the data is spread across 20 plus or minus 2. That is one standard deviation, okay? Mm. And rest is almost not as such major differences there. But here in exam score, the mean is 69 and standard deviation of exam score is 16, which is actually really high. We have to check for the outlier in this. We will check. So yeah, first let's discuss about missing values. So first is you have seen that in parental education level, there has been 91 missing values. So, so for missing value, there are, I think, majority of uh, two things you can do about. First is you can drop the missing value. You can drop a particular row that has missing value, or you can replace it. So that decision to whether replace or drop, it's totally depend on which data set you are working, how many rows do you have, and is it even possible to fill fill those missing value or not. So here, the missing value is parental education level. So let's first see what is parental education level. So I have explained the column. There are 909 different unique values are there. Sorry, different values are there. Unique values are only three. And topmost, which is the mode. Mode is a, have you, I think you heard the name mean, mode, and median in 10th, 12th, or in your schooling. So the mean is average. The mode is a most frequent value. So here the top represent most frequent value is high school. Okay, and the frequency count is 392 out of 909. And these are different values that parental education level holds: high school, bachelor's, and master's. And the most frequent value is high school. And you can see that we only have a data of 1000 rows. So it's not as much data, you can say. So I I have decided to, fill those missing value rather than dropping it. Okay. So let's just here I also check the percentage, how many percent of the values are distributed. That high school is 43%, bachelor is 38, master is 18%. So it's more suitable to put high school in all those missing value. There might be some bachelor case or master case, or might be other case, but as of now for the analysis, it's good to put high school values. Okay. So I also plotted the difference between the all the values bar chart. And here is the code by doing df, that particular column, parental education level, equals to df parental education level dot fill na df dot mode bracket 0. Why we are doing bracket 0? Because whenever you are doing mode, it will give you a numpy series or series, I guess. So it will be a row and column values. To get the first value, you have to put 0. So that's why we are putting 0 in here. And after that, you can check that is it is that all the null values or the missing values has been replaced. So yes, it's replaced. Whenever I'm doing is NA sum, it's showing me 0. Okay. Yeah. So let's just quickly move ahead. Checking duplicates row. I have checked duplicate rows. There are no duplicate values here. I've also checked the student ID. It's student ID column. It doesn't add any value to the overall habits and the academic performance. So I've decided to drop that column. So after dropping, you can see I have checked the how my data set is looking. So now we have, I think, 15 columns. And here I have plotted some different kind of graph to represent how each column or multiple column represent. That's called univariate if it's single column, and bivariate if it's a two column, or multivariate if the analysis has been done in more than two columns. So first has the histogram of age. You can see it's a kind of almost uniform. The next is gender. So univariate analysis is category feature. This is a numeric feature. Okay. So in category feature, you can see there are three categories. There are 48% male, 47 female, sorry, reverse, and 4.2 others. We also have done the category feature of an analysis of category feature, part-time job. You can see majority of students are not doing any part-time job. Around out of 900, out of 1000, almost 800 is not doing any part-time job, and only 200 around doing part-time job. This is the distribution of exam scores. You can see it's a kind of a left skewed data. So majority of data is on right side of the data. That's why it's called left skewed. There are few students who also get 100 out of 100 marks. Okay. So this is another category, diet quality. Yeah, this is a scatter plot of study versus marks. So you can see the it's showing a good positive relation that number of hours you study per day will increase your exam scores. Okay, this line showing this is a positive correlation. You can also see I have plotted correlation metrics here. Here you can see exam scores and study hours per day correlation is 0.83. That shows a really good relation, positive relation. Okay. And this is again the histogram of all the numeric columns. And yeah, the next part is outlier detection. So there are multiple ways you can detect the outlier. So here I'm using today's IQR, which is interquartile range, you can say, in statistics. So it's basically Q1 is 0.25 percentile, Q3 is 0.75 percentile. And if you have seen the box plot outlier, so this is the uh, yeah. So this is the IQR interquartile range, Q1, Q3, and this is the formula to find minimum and maximum threshold. The minimum is Q1 minus 1.5 into IQR, and maximum is Q3 plus 1.5 into IQR. Before and after this, all values which are remaining, you can consider all of them as outlier because they are minus 3 standard deviation or plus 3 standard deviation away from the mean. Okay, it is what we are doing here. So, okay, we are finding the outliers, how many outliers are there for each column. Here you can see that in age, 0 outliers are there. In study hours, 7 outliers are there. In social media hours, 5 outliers are there. Netflix have 4, 3, sleep hours have 2, and exam score have 2 outliers. So I've also checked the individual outliers that you can see in study hours, the outliers are on higher side. That some students have studied longer hour on each day, which is 8.2, 8.3, and that is considerable. That might be possible. Some students are really working hard. So I have not decided to drop it or uh, remove these outliers. I have decided to keep all of them because mostly all of them are looking logical and considerable. So you can see in social media hours, there are few students who are using social media 7 hours a day. That might be possible. Netflix is also 3 hours, 5 hours. Attendance, some students have 56% attendance. Yeah, that might be a case. Sleep hours is 10 hours is outlier. So some student might sleep 10 hours a day. And exam score are actually the lowest in the lower side. Some students get 18 out of 100 or 23 out of 100, and that still be possible. So I have also the conclusion in this file. Since the detected outliers are realistic and plausible, they should be retained. They may capture rare but important cases such as extreme behaviors. Okay. So if any outliers are like, such something that you cannot realistic, suppose in one outlier is if you out of 100 marks of exam, some students getting 120. That's an outlier that cannot be possible. So you have to remove that kind of outliers, which is unrealistic and not it will hamper your model basically whenever you're building any model. Yeah, one of the most important thing is feature engineering. So we today I'll explain you two kind of encoding is one hot encoding and label encoding. So what is one hot encoding? So here So encoding is basically apply on categorical values. So why we are doing encoding? So encoding is basically converting categorical columns like uh, height, no, not height, but like you can say here, what we have is diet quality, fair, good, bad, parental education level, master. There are three categories. Internet quality, there are also three categories. So that kind of gender, male or female. So in encoding, what we are doing is converting those string or categorical values to numerical values. So the reason why we are do this because model understand numbers more better than a string values. And I think it's true for any in computer science. You can see that everything is number. So in hard coded, everything is zero or one binary. On top of that, we have built all the languages, all the OSs, all the UIs and everything on top of that. But in core, everything is zero and one. So it's generally good practice to convert your categorical value in a numerical value to understand your model to help your model to understand better. Okay. So first we are converting gender to uh, one hot encoding. So in one hot encoding, you just convert your gender into suppose you have male or female, you convert those two categories into two columns, and one is zero and one other is one. Okay, so here and when you put you actually use dummies pandas.get dummies command to convert your category column into one hot encoding one. When you put drop first is equal to 2. So it will basically drop any one column which is not required. Basically, if you have male, female, and others, and male, female values is 0, 0. So I think you get that this person is a fall in the other category. So that is the reason. So yeah, we have done for extracurricular partition, same not encoding. So for all the values, generally the good practice is to keep not to do and one hot encoding in a target variable. So that will be gives you multiple columns as a target variable. But you can do in your input variables, input data. And if generally is nominal, it means that the data order does not matter. You can do one hot encoding. And I have another example. Yeah, diet quality. So diet quality is a ordinal data, right? So ordinal means the order matter. Name in itself, you can say order matter. Suppose if you have present poor is 0 and fair is -1, that's not true. So it's increasing. The number of value increase that represents something. So that's why it's order matters here. So here you would perform ordinal encoding, which is also called as label encoding. So you just basically replace a category with a number, increasing in order, or maybe depend on which column we are doing. So here we have done that. And last, there are basically two major transformations. There are actually a lot of transformation. Today we also only learn about this only one min-max transformation. So what min-max transformation is do? So earlier you can see here your values are are variety of values, right? Here the values range is between 53, the exam score is between 0 to 100, mental health rating is 1 to 10, education is 0, 1, 2, or 3. This we have converted in label encoding. So all the different column values are in different units. So you have to get it all in one unit. So you use min-max transformation. So what min-max do is it will the min-max will there's a formula of min-max is x minus min and max minus min. Let me explain you min, max. Yeah, x. So any particular value subtracted by that particular column's minimum value divided with that column maximum value minus minimum value. If you perform this operation in all the data, it will give you the value in the range of 0 to 1. So yeah, you can see after what we have done, we got all the values in 0 and 1. So it will be a better to um, do a min-max transformation because some machine learning models do understand better, do learn better, and the ranges are between range. Okay. Yeah. So that's it from my side today. Thank you for watching. Bye. Good day.